Okay, so talking about linear modeling, we're going to go over independent, dependent in a second. And I was just about to ask you, what do you need to write the equation of a line? What information would you need? Yes.
The slope.
I would need the slope. What else do I need? Yeah. If I had y-intercept, I could get there. What else could I use? Yeah. Some other point on the line. Now, what if I'm not given the slope? How do I find slope? If they don't just come right out and say the slope is 7, what do I need? 2 points. So would you agree that if I had 2 points on a line, I should be able to write the equation of it? Because that would get me enough information to find the slope, and then I can just use point slope form or y-intercept and get all the rest of the pieces that I need, right? So basically what I'm going to be doing is reading through the problem and seeing if there's bits of information that are basically 2 points on the line. And then once I have those 2 points, I like to just organize them in the T-chart so I have them there. It's nice, organized, and then no matter what the 2 points are, now I can write an equation for it. All right, so that's kind of what we'll be practicing today. Once I have those, and depending on the information that I'm given, I have my 3 forms of the line. I'm going to use whatever makes sense. So if I have just a point and a slope, if I have a slope and a y-intercept. But we do want to be rewriting these in function notation. All right, so remember, function notation, f of x replaces y. They really are the same thing. Okay, but now, if I have it in function notation, I'm sort of setting myself up to be able to answer for the questions on the word problem. Okay, so let's go back to determining independent, dependent variable, and then we'll try a word problem and do it all the way out. Okay, so if you look at the next sheet that I gave you, this is just some practice figuring out which one's which. So I have a little thing that helps me. Whatever I'm doing, I like to kind of rephrase it in this form. I like to figure out, okay, blank depends on blank. So you'll see in a minute how this kind of comes together. Whatever I'm putting here, this is the dependent variable. And this guy over here would be the independent. All right, so let me do example 1 for you so you can kind of see my method anyway. So number 1 reads, a study was done to find if different tire treads affect the braking distance of a car. So I'm going to ask myself, all right, well, what's being compared here? It's tire treads and braking distance. So I'm going to ask myself the phrase in my head, okay, so do the tire treads depend on the braking distance? That doesn't seem to make a lot of sense. But does the braking distance depend on the tire tread? Yes. So braking distance depends on tire tread. Do you see that? So that's the phrase that makes sense. And now I have, oh, okay, so my dependent variable was the braking distance. And the tire tread is the independent. And remember, independent is really your x values, and these are your y values. So I'm going to input some amount of tire tread, and it's going to output for me what the braking distance would be. That kind of makes sense? Let's try the second one. The time it takes to run a mile depends on the person's running speed. Well, this one, it's already set up for me exactly in my form, right? The time it takes to run depends on the person's running speed. So if I were to fill in my blanks, it's already there. So the dependent, right, is the time it takes to run. Time takes to run. And then the independent would be the person's speed. I'm sorry, dependent. Oh, did I put him in the wrong spot? Yeah, no, I didn't. Time it takes to run depends. Yeah, so independent is my running speed. Three, you try it. The height of bean plants depends on the amount of water they receive. So the height of the bean plants depends on. So that means the height of the bean plants is the dependent. Height of plant. And then the independent would be amount of water. Does this make sense? Now, Ford, they don't use the word dependent there. So to see if you can figure it out with 4, how would you insert that word dependent so that it makes sense? The higher the temperature of the air in the oven, the faster a cake will bake. So ask yourself, does the temperature depend on how fast the cake will bake? That seems a little weird, but try, will the speed the cake bakes at, does that depend on the temperature? That sounds right to me. So what's the independent in this case? Temperature. And then the dependent would be, time cake bakes, let's say. So let me give you, like 3 minutes. Try the rest of them, and then we'll compare. I wonder if I can pause the video. Okay. Anybody want to give me the answer for 5? Lemon trees receiving the most water produce the most lemons. Give me the independent and dependent. Aiden, go ahead.
The independent is more water, and it said the dependent is more lemons.
Sure, yeah. So you're getting more lemons depends on getting more water. Okay, so make sure you've got lemons over here, water over here. 6. An investigation found that more bushels of potatoes were produced when the soil was fertilized more. Who's got this one? I know you all do. You just gotta read for me what you wrote on your paper. Or should I call you at random? Guess I'm gonna have to. Oh, go ahead, thank you.
Wait, this is
6, yep.
the independent is the fertilized soil, and the dependent is the amount of potatoes produced.
Perfect. Number of potatoes is going to depend on your fertilizer. 7. Students measured the temperature of the water at different depths in Lake Skywalker and found that the temperature varied. Go ahead. Right. So the temperature depends on the depth that you're at, that you're measuring at. Okay, and this is the last one, right? Nope, just kidding. 8. The amount of pollution produced by cars was measured for cars using gasoline containing different amounts of lead. Go ahead.
The independent is the amount of lead, and the dependent is the amount of pollution.
Exactly. So the amount of pollution they produce depends on the amount of lead in the gasoline. And last one, 4 groups of rats are first masked and then fed identical diets except for the amount of vitamin A they receive. Each group gets a different amount. After 3 weeks on the diet, the rats' masses were measured again to see if there has been a decrease. Which is which here? First, I mean, there's a lot going on in this problem. There's a lot of extra information that for this particular exercise we don't really need. We just need the 2 quantities that are kind of going, what are they? Yeah, go ahead. Tell me.
The independent is how much vitamin A they receive, and then the dependent is the mass.
Exactly. So it didn't matter all the extra stuff. Sometimes you, if you're actually doing an experiment, I'm sure in science you've talked about having the constant, the things that you need to keep identical throughout all your trials so that you're only testing one variable at a time. So in this case, that's why they made a point to say the diets that the rats were fed were identical, save for the vitamin A, right? Because if you're feeding them different foods, well, that's going to change everything. All right, so we're okay sort of with this little exercise? Yeah? All right. So if you go back to your note sheet, we're going to flip it over, and we have a couple of problems to try here. So let's read and see if we can kind of wrap our minds around how we handle these. So the first one reads, for a banquet, a restaurant charges $300 to rent the facility, plus $60 for each guest. Model the total cost C as a function of the number of guests N. Alrighty. So I'm going to make myself a little tea table. And then I'm going to ask myself, okay, does the cost depend on the number of guests, or do the number of guests depend on the cost? Which way does it go? Yeah, the first way I said, right? The cost depends on the number of guests you have. So that means my number of guests is going to be my independent variable, which is X. So I put it over on this side, and then C will be my dependent variable. Okay? So they didn't actually give me, they gave me some information, but they didn't say, hey, if you have 10 people, it costs this much. But I could kind of figure it out. What's the easiest number to work with usually? 0. If I don't have any guests, how much is this thing going to cost me? It's going to cost me $300. If I go to a place and I say, I'm booking an event, right? I say, I want to have an event. They're like, okay, it's $300 to rent the room, and then everybody that comes is going to be an extra $60. If no one shows up, I'm still paying that $300, right? So, nobody comes, I still had to pay $300 to rent that facility. And now, I mean, you can, if they don't give me the numbers, I can pick however many I want. I could say, okay, well, if I had 10 guests, I could do the math. But why not just make it easy on ourselves? All right, if one person shows up, it's 360. And now, guys, I have everything I need. Don't I have 2 points? Yeah, so I can write the equation of the line. I know this one is a little bit easier because you kind of already know what the slope and the y-intercept are if you kind of read through the problem, but they're not always going to be so clear-cut. So it's helpful to kind of go through the process on an easy one that you know probably what it's going to look like, so that when they get a little bit more muddled, you can still sort of find those things. All right, so if I have 2 points, which is essentially what I have, I need to find the slope, right? So again, I know you know what the slope is probably, but you won't always, so it's helpful to just sort of go through the steps so we have it all written out what we should do. All right, so there's my slope. And this time I'm lucky because I actually do have the y-intercept, right? I know when x is 0 what y is going to be. So I don't actually have to start at point slope form and then rewrite it, because now I have my slope and my y-intercept. So normally, if I'm just writing the equation of a line, I'm writing it as y equals 60x plus 300. However, we want to be in function notation. And I'm not using x's and y's, really. I'm using the c and the n business, right? So here's how this is going to look. If I'm writing the total cost as a function of the number of guests, it looks like this. Cost is a function of the number of guests. And then instead of x, I just have the n. Does that kind of make sense? So now I'm all set to input any value I want for n. So I can see how much it's going to cost for a 10-person event or a 1,000-person event. It doesn't matter. Okay, does that kind of make sense? All right, so again, I know if you read this, you can jump right here, but we won't always be able to. So let's read the second one and see if we can sort of decipher our way through this one. From 1990 to 1996, the population of Oregon, or how do you say it? Oregon? I say Oregon. I don't know if that's wrong. Anybody from Oregon? Oregon? Who knows? Anyway, this state increased by about 60,300 people per year. In 1996, the population was about 3,204,000. Write a linear model for the population P of Oregon from 1990 to 1996. Let n be the number of years since 1990. Okay, so does the population depend on what year it is, or does the year depend on the population? The first way, right? The population depends on what year it is, not the other way around. That would be weird. So, if I set up my little T table, now, I do have a value. They gave it to me right here. I don't know if you noticed it. They gave me one. There's a point. In 1996, the population was this. Do you see that? So they gave me a data point. What do I put down right here for n? N, remember, stands the number of years since 1990. So I'd put a 6 right there, because it's been 6 years for 1990. That's what I'm setting my variable to represent, years since 1990. Okay, and then P is the population. So the population at that time, 3,204,000. Okay, cool. But they only gave me the 1 point. I don't have a second point. Yes.
Wouldn't 1 year be 60,300?
Well, so let's go back and read it. It says from 1990 to 1996, the population of Oregon increased by about 60,300 people per year. So it's not saying that was its population in these years. That's how much it increased by per year. But I can use that information to get myself a second data point. So tell me describe what I should do.
You should add an extra year, which would be 7 years, and then you could just add 60,300 to the population.
I love everything you said except one teeny tiny problem. If I add a year, then I'm going to be at 1997. So, and I don't know that it kept that pattern. So I should subtract instead. So let's go back a year, and then I can do the same thing. I'll just subtract the 60,300 from the population. So in 1996, I know what the population was, and I know that it had been growing at 60,300 per year up until that year. So we can just backtrack 1 year and get another data point. Okay, so at 5 years, let's figure out whatever that is minus 60,300. Minus 6,300. Okay, 3143700. Just a note too, if you had done what Jared had suggested, since this is a linear model, it actually wouldn't have mattered, right? Because this is just a straight line. But we do just want to be mindful, we only have the information for this range. So I don't want to step out of that if I can avoid it. Okay, great. Now I have 2 data points. So I should be able to write the equation of my line. It's just annoying that I have big numbers, but it is what it is. So I can find the slope. Oh, that was dumb. I already knew what that difference was going to be. Silly goose. Okay, and this time I don't have a y-intercept, so I'm just going to pick one of my 2 points. So I don't know, I'll just pick the first one. Y minus 3,204,000. My slope is 60,300 times x minus 6. Great, so now I'm here, and all I have to do is rewrite this so that it's in function notation. So let's go ahead and get that y by itself. Distribute that 60,300. I think I have it right here, times by 6 is 361,800. And we'll just add this over. So I should end at 2,842,200. And then all that's left to do is rewrite that in function notation. So the population as a function of the number of years since 1990 Okay. All right. So let's read the last one, and maybe I'll give you a minute, see if you can come up with what you need to do. In 1990, retail sales at bookstores were 7.4 billion. In 1997, sales were about 11.8 billion. Write a linear model for retail sales are in billions of dollars from 1990 to 1997. Let n be the number of years since 1990. Well, let me help you get it started. Does the year depend on the retail sales at a bookstore? That sounds awfully weird, right? Could you imagine? Oh, retail sales were 12 million. It must have been 1996. No, it doesn't work that way, right? The sales depend on what year it is. Okay, so we'll have n the number of years. R is going to be my retail sales. Now, in this one, they actually, if we read this carefully, they gave me 2 data points, didn't they? In 1990, sales were that. So there's a data point, 1990. There's my retail sales. So what am I putting in for N for the year 1990? 0, because we've established that N is going to be the number of years since 1990. So if it is 1990, that's going to be a 0, which is also pretty cool because now I have a y-intercept. And then 1997, sales were 11.8. So what am I putting in for N for 1997? 7, and then I got 11.8. All right, go ahead and write this equation. Do what you need to do. Write this. Make sure you write it in function notation. Okay. So just a note, I got rid of the decimal and a fraction. If you didn't, I mean, it's not the end of the world, but yeah, we typically don't like to have, same thing, you don't want to leave a fraction and a fraction. Just a good habit to not leave a decimal and a fraction. Okay, but is that all right? So in this particular one, they didn't give me any kind of a slope, so I had to find the slope myself, but they gave me the 2 data points that I needed. Okay, so really a couple of different styles. This one, they literally just come right out and give you 2 points. Here, maybe they give you 2 points, but not really. They give you 1, but they give you enough information to find the next one, right? Or they might give you, like on the top one, they just come out and kind of give you the y-intercept and the slope. But you can use sort of the t-table, if you need to sort of help organize your information. And just look for those 2 points, because once you have 2 points, you're golden. You can do the rest of it. Okay, so let's stop this here.